Hello everyone, welcome back to my channel. This is Vikas here, and today I will be starting with the day one of 60 days of DevOps with Vikas series. So let's get started with this. So before getting into that, I will be explaining about the mind map. Okay, so that it would be easy for you to remember these things easily. Okay, while you will appear for any interviews as well, this is going to help you. Okay, so first thing will if you are starting with the DevOps, first thing should come to your mind like why DevOps. Okay, why it came in picture, correct? And why DevOps? If we are thinking, we should also think what was before DevOps. Okay, what was before DevOps? So before DevOps we were following, there were some traditional methods. It is called traditional methods, like we were following waterfall model. Like this, what we are discussing, this is one of the favorite question of an interviewer. What is waterfall model, what is agile model, and what is DevOps model? So first time I have started with the mind map so that it will be easy for you to correlate the concept. Okay, this is a very unique approach so that it, and after that only after these two only your DevOps strategy or DevOps method came. Okay, after these two. So we will understand about what is waterfall model, what is waterfall model, okay, and its drawback. We will see more than that, but this is just an overview. Okay, like whenever you are preparing for DevOps, you are getting started with DevOps, these are the question you should ask yourself. Okay, here also, what is agile model and what are its drawback? So in the what question, in this question only, we will cover like what is waterfall model and its different strategies, what are its different strategies. Okay, and why we have neglected this, we will see that as well. Coming to agile model, we will see what is this agile model. Okay, we will see what is the strategy. So just remember this complete mind map and sit with a pen and paper so that it will be very easy for you to understand these complete scenarios. Okay, once we will understand what was before DevOps we were using, then we will come for waterfall model, then we will see agile model, then we will see the drawbacks as well, then we will go for our DevOps approach. DevOps approach, in this what are all the things we will see? Okay, first thing we will see what, we will ask what is DevOps model. Okay, okay, and apart from that how it is helping us. So the question should be like how it is making the human life easy, IT department life easy, correct? Or you can say human life easy. That is the main motto of any new tool, right? So apart from that, what we will see, it's strategy. Okay, strategies, like there are various strategies it have. Okay, and into strategies, what are all the things we will see? We will see continuous deployment, development, testing, and monitoring. So this is very important to understand if you are a beginner or you are a pro into DevOps, but still you should be aware of these all terminologies. Like if you are not aware about how it's been evolved, it is very hard to understand, right? So we will see different strategies: continuous development, deployment, continuous testing, and continuous monitoring as well. Apart from that, what we will see, we will see the DevOps life cycle. Okay, this is one of the best, you can say this is one of the hottest thing here. Okay, that we need to understand. Okay, so this much we will see, and in the last we will have our uh we will briefly see about the DevOps tools. Okay, so while explaining these all strategies, I will be defining at this stage what are all the tools and technologies we will be using, how it will make our life easier. Okay, so this was the complete mind map, guys. So these if you will talk about what are all the main questions we will be getting from here, the overall heading you mean to say why DevOps, correct? What is DevOps? This is going to be your second question. So this is the overall heading. Okay, but these are the key point which we need to cover into this topic. Okay, what is DevOps and DevOps strategies, or you can say methodologies. Okay, so let's get started with why DevOps came in picture. Okay, so before that, what I have told you, before knowing why DevOps, we should understand like what was before DevOps. Okay, so first thing you should keep in mind. Okay, first thing before DevOps, there was two team, like there was a development team and there was a operation team. Okay, two teams were there. So development team were involved in development, like writing the codes, then building the codes, then there was a testing team, and then there was a QA team, quality assurance team. And this is I'm talking about before DevOps. Like there was two team develop, one team was having developers who was writing the code, building the code, then there was a separate team for testing and separate team for QA. Into operation team, there was a person sitting who was deploying the codes, whatever they have, the development team will provide you. And there was a team who were maintaining, and they were monitoring as well. Okay, then everything was going smoother. Then you will be thinking, then what is the issue? So what was happening whenever in this scenario, like it was something like development team versus operation team. Why? First thing is they were playing blame games. They were playing blame games. Why? Because development team wrote the code, correct? And when operation team were trying to deploy the application, where on the client side, so when development team has wrote the code, okay, then operation team was trying to deploy the code onto the client side, they were not able to do that. Okay, it was not getting installed properly. Okay, but the development team is saying it is working fine for me, working fine for me into the developer system, right? So that is why they were blaming each other, correct? So as a DevOps engineer, or if you are a beginner, what do you think, what could be the issue? Okay, so what you can think of, like maybe there should be a issue of something like supported library or missing library, right? Libraries in the sense like whenever you install any kind of software. Okay, so the software may require some kind of package already to be installed into your system. Okay, then only you would be able to install this, something like prerequisite. Like this course is a prerequisite for your DevOps journey, correct? Without these basics you will not be able to understand. After that you will be pro. So that in the same way, this, to run any kind of software, there should be some supported software or library should be already running. So the developer were saying, coming to the topic, it is already running into my system, but when the operation team is trying to run the same application, they are unable to do that. So because development team were maybe having these all libraries, supported libraries and things, but operation team doesn't have. Okay, second thing, what could be the issue? Maybe the OS versions, operating system version. Maybe the developer is using Windows 8.1, and the operation team is using Windows 10. Okay, so this can be another issue, right? And the third thing can be either maybe it could be a hardware or software version issue. It should not be hardware, it should be mainly due to the software version issue. So you can see these are the issues they were facing. Apart from that, what else issue they were facing? Here, into the development team itself, when the developer was handing over their code to the testing team, in their system the code was not getting installed, again due to the libraries and software missing or the version mismatch. Okay, so think like somehow the developer helped the testing team to run the application. Again, when the testing team has handed over the code to the QA team, again they are saying it is not working in my system, right? So you can see such kind of issues were occurring that was delaying the project releases. Okay, so instead of development into the interdependent development team, it was also an issue with the development versus the operation team. So that is why going forward you will see how like Docker came in picture. Docker image came in picture, like to build the application, development team will do what? Along with the code, they will write a kind of Docker file, right? They will package into some image, right? And they will send it to different team, either it is testing team or it is QA team or it is some other team. Okay, so like this you can see how these kind of dependencies has been resolved by one of the use cases or one of the DevOps tools using Docker image. So in the Docker image you will be writing what is the image version is used, what is the code has been compiled, right? So this is just one time activity, but the image you will get, based on that your testing team will create a container, your QA team will create a container, and your another team will create a container. They will not get such dependencies error of library missing, the OS version or the software version. They will not get these all things. If you don't know about this Docker concept and all, I will be explaining into the day 3 or day 4 lecture. Okay, as per the plan we will go ahead. Okay, so just a quick reminder, if you have not subscribed to my channel, please do subscribe, because and also hit the bell icon so that you will always be updated with the latest video of this 60 days of DevOps with Vikas series. So let's go back to the topic. Apart from that, like what were the two main issues we have saw here? Let's recall that as well. Two main. Okay, so first one was development team development team versus operation team, right? Why? They were playing the blame games due to the version issues or the software mismatch or the hardware OS version mismatch. Okay, and second was, these all things was a manual process earlier. When these all things were happening, when we were following the traditional ways, there was no any sign of DevOps till now. Okay, before DevOps I'm talking about, if you remember, I'm just recalling this. And third thing was the process was time consuming. Why? Correct. So don't you think, like take a simple scenario. Okay, if a company A given you to develop a application. Okay, you told it will take around 8 months to develop this software. Okay, software or application. So if you will go with this previous approach, right, what was happening? Due to these all issues, the project was getting delayed. And if it is taking 8 months, some company has done what? In within 6 months only they have launched the same kind of application. Okay, so now this team has been wasted their time, right? Somebody else came with the same software. So that is why speed and accuracy is required here, that you can achieve using DevOps tool. So now, once we are aware of like before DevOps and why DevOps, okay, we will go for before DevOps thing. Okay, we will see more example on this. Okay, so before DevOps. So as I told, before DevOps we were using waterfall model. This is very very important topic. So what do you mean? What is this? This is a kind of software development life cycle. Okay, software development life cycle. So if we talk about waterfall model, so it is a linear kind of model. Okay, and basically it follows top down approach. These 2 points just keep in mind. So waterfall model is a linear model, you can say, and it follows top to down approach or top down approach. Okay, so now if we understood what is waterfall model, then we should understand about the phases. Okay, so what are all the phases we have into the waterfall model? Okay, so first phase comes like requirement. Okay, into requirement, basically what happens, we we gather all the information about the requirement from the client to develop an application. Okay, so this is, again I'm repeating, in this phase we basically gather all the information or the requirement from the client. Client is the person who gave you to develop this application. Okay, so to develop an application, okay, so what you will do in this phase, you will analyze it. You will analyze it. Apart from that, you will now proceed with the with another phase. Okay, after collecting the requirement, we will go for design phase. So this is, guys, from top to down we are moving. We have collected the requirement, all the information from the client, so that we can develop the application. Once we have analyzed it, we have proceeded for the design phase. Into the design phase, basically we see like how the application will look like. Okay, and basically we create the blueprint. Blueprint is a kind of soft blueprint is a kind of, it is going to be a design diagram where you will be showing like what how the login page will look like, how the registration page will look like, and what is the connection, what is the database things. You will define each and everything single detail here. Okay, once the designing phase will get completed, what you will do then, into waterfall model we go for implementation phase. So from the name it is clear. Now in this phase we will begin coding of application. Okay, so how the application will look like, we have the blueprint, then we have went for implementation only, correct? Based on that you will write your code, your front end and the back end, right? Once the implementation phase was done, we have verification phase. This is a verification phase where once you have done with the coding, you will do testing of the application. You will check the bug fixes and whatever modification or validation which is required. All thing will be done testing here. Once the testing is done, you will be basically deploying the application to the production server, and you will make it live. Live means it will be accessible to end users. Okay, end user will be able to access your website, and once you have made it live, then what happens, then it goes for monitoring phase. Monitoring phase. So here basically, once your application is running, what you are doing, you are monitoring the health of your application and your application server. Okay, so these are the phases of waterfall model. Okay, so now we understood what is waterfall model and what are the phases or strategies of a waterfall model. Now we will see. So you will be thinking this is a good approach, right? From the top to down, each and everything is in place, right? So why do we neglected this thing? Okay, so let me go ahead with the drawback of waterfall model. Okay, so what was the first drawback you think from this model? Okay, so unless one stage or one phase will not get completed, you can't go for next unless and until you have gathered the requirement, you have made the design, right? By connecting with your client, like this is how your login and registration page will look like. You cannot start implementing the code. Okay, so you can see there is such a dependency, right? So in this is a kind of dependency, you can say. So unless once one phase will not get completed, we cannot go for next. So first thing, it was time consuming. Okay, because there was a linear kind of dependencies. Implementation will be done, then only verification will be done, then testing of the application will be done, then only your testing of the application will be done, then we will made it to live, right? To by deploying onto the production, then only some team can monitor the application. So it was time consuming, right? And apart from that, it was not suitable for today's world scenario, in the sense, like right now, if you are aware, the requirements keep on changing. Okay, suppose the team has written some login functionality. Okay, team has written some login functionality. Okay, but he showed it to the, but once the application has been made live. Okay, once you have made the application live, then the client asks you to change the login page. Okay, ask you to change the login page design. But when you will go from waterfall model, again you have to go with this way. Again, you have to collect the requirement, you have to modify the design, you have to start the implementation. Once you will implement it, you will go for the verification, and once you will launch the application, you will deploy the application to the production, then monitoring can get started with the newly deployed changes. So you can see how hard it is to make the changes. So in this way, you can see there is no way of of getting a feedback, right? You cannot show something to the client. Okay, you cannot show anything, any product to the client till you deploy the application to the production server, right? So that was a major drawback. Until and unless you will finish the application completely, you cannot show it to the client, right? So in the last, if they are saying you to make the changes again, you have to follow the same steps again and again into this linear way. Okay, so hope you have make point of that. I have not written completely here. Now after this, so as I told, DevOps is a evaluation of from waterfall traditional methods like agile method, waterfall model. Okay, now we will see about agile model. So after waterfall model, this agile method came. Okay, in this agile method, what is agile method first? So in this method, what we have done, we have broken down the software into various stages, or you can say iteration. So we have broken software into iteration various iteration, in the sense you have made different, you have made a separate phase for planning, you have made separate iteration for design. These all are going individually. Okay, and you have made separate phase for development, and it will go for next stages as well. Correct. And as you can see, this is not linearly dependent. So what we have done, instead of this, instead of making it like this, what we have done, we have made it completely separate. We have separated into various iterations are planning, our design phase and our development phase, and next phase like your testing and the deployment. Correct. So in this phase, the duration was something like 2 week to 8 week maximum, minimum to maximum, right? In 2 week you will do the planning, then you will go for design. You within 2 week or 8 week maximum, you have to finish this thing. Okay, but what happened with the agile model? Okay, so what is the drawback, why we are not using this now? Okay, you will be thinking. So sorry, before that, before drawback, let me explain you more so that it will be easy for you. Okay, so we have seen what is agile model. Now we will see like what was happening into this agile model. Okay, how it was basically functioning. Okay, suppose you are a developer. Okay, you have released the first version of the application. Okay, and what you have done, you have made it live. Made it live in the sense you will deploy it to the production server, so end user can access it. Okay, in this phase what you have done, you have gathered some feedback. So it is a developer plus operation team, right? Still, so developer plus operation team released the first version of the application. They made it live to the end user, they deployed onto the production, they have gathered some feedback. Okay, so after getting the feedback, again they have done what? They have released second version. Second version with whatever feedback they have received, they have incorporated. Incorporated means like there will be some bug, right? Your site is lagging, your login validation is not working, such kind of thing they will get. Okay, so in the second version, whenever the devops team will launch the second version, they will try to fix those bug as well. Again they will do what? Again they will deploy. Okay, again they will deploy. Again they will collect some feedback. So again in the same way, third version has been released. Again it has been deployed to the production, operation team has deployed to the production, and again we have gathered the feedback, and this way will keep on continue. Okay, so this was all about the working principle of agile model. So obviously it was better than which model we have seen? Waterfall model, right? It was basically better than waterfall model because we have minimalized the dependency thing, right? In the waterfall model we have seen like it was linearly dependent, so we have broken down into different iteration. People were working on planning, then designing, then development, right? But what were the drawbacks? So in this the main drawback was like operation team were not coming up to the speed with the development team. Okay, so the development, so here also somewhat the blame game was happening. Okay, where the operation team was not maintaining the the step, sorry, the speed with the development team. Constant conflict and between developers versus operation team. Apart from that, the main thing was it was still hampering the release goal. Release goal is something like this is the deadline in which the project should be completed. Okay, but there was the conflict between, always constant conflict between the developer and the operation team due to the dependencies and many kind of thing, right? It was hampering the release goal. So these were the major drawback. Okay, now we will go for the most important thing, that is our DevOps approach. Okay, so into DevOps approach, so let me give you a quick walkthrough of what are all the things we have understood till now. We have understood why DevOps, we have understood before DevOps, we have understood what is waterfall model, what and what is the strategies it follows and what are the drawback. Then we came to agile model, we see what is agile model and how does it function and what was its drawback. Then we will see now what is the DevOps approach, and these are the things we will see: what is DevOps approach, how it is going to help us, what is its strategies, and what is DevOps lifecycle. In the strategies, we will see these four things: deployment, continuous development, continuous testing, and continuous monitoring. So let's get started with this topic. So with the term DevOps, okay, now the old era has been ended where we were using the traditional method like waterfall model and agile model. Now a new approach came, that was basically a combination of, that was basically a combination of two things: development plus operation. And using this we made a single team that is called DevOps team. Okay, so now we have mitigated the issues between the development team and operation team and we have made a single team who will take care of the development as well as the operation team. So this doesn't mean you should know, a DevOps engineer should know about the coding thing. Okay, they, that is not required, but still they would be able to know the functionalities of the code. Like if the code is written into Java language, he should know about the pom.xml file. pom.xml file, right? He should be able to read this file because this is very, very important in order to deploy the Java application. Correct. So he will be continuously in touch with the development team. So what are all the things this DevOps engineer will take care? Okay, let me show you. So as we have seen into this development versus operation, okay, now DevOps engineer will not do this development activities. Correct, they will not be the part of these development activities, but he will be the part of rest of all other thing: building, testing, deploying the application, maintaining the application, and monitoring the application. Okay, so there is a single person who will be able to do these all things. He is called a DevOps engineer. Okay, so first point we have noted, it is a combination of team two team, and we have merged the both team into single team, that is called DevOps team. And second thing, you can see DevOps is a practice, or you can say culture. So it does what? It allows a single team to manage the entire application in the sense the software development life cycle will be managed by the single team, right? And now, like the single team, so what are all the things he should be taking care of? The development. Okay, this is not required. Correction. Third thing is, you can say it is a software development approach. Okay, in this, what is the end goal? End goal is to deliver a high quality software which will be developed quickly without any manual work or intervention, you can say, using automated tool. So apart from that, you are increasing the reliability. Okay, and this consists of various stages, right? So what are all the things? Let's revise it first. What is a DevOps approach? It is a combination of two things where development and operation team has been merged into a single team, that is called DevOps team. It is basically a practice or a culture of a software development life cycle where a single team will manage the entire software development life cycle. It is a software development approach where the end goal is to deliver a high quality software quickly without any manual work. Okay, or it will be automated through tools, various tools like Jenkins, Ansible, Terraform. Many tools are there, we will discuss on that, and it will make us more reliable. Okay, and the DevOps approach consists of various stages. Okay, we will see what are all the stages we have. So we are having, so this word is common, so that is why I'm making the mind map for you. So what are the things we will have into it? We will have continuous development. Okay, we will have continuous testing. We will have integration. We will have continuous deployment. I will tell you about these all things, what does this mean. Okay, and the last thing is going to be continuous monitoring. So these are the various stages a DevOps approach will have. Okay, and we will talk on these topics briefly. Before getting into that, let's see what is the aim of DevOps. What do you think? Aim of DevOps is to shorten the software development life cycle. So we should be able to minimize the timeline, right, to deliver the software. So now you have the tool like Jenkins and Ansible where you can manage, like, see, shorten the SDLC means, like, suppose you are developer is this is a developer. He wrote the code, okay, and pushed it to the GitHub. Okay, there will be a operation team. He will, sorry, this is the DevOps engineer. Now he will pull all the code from the GitHub, right, the latest changes from the GitHub, and he will be using a Jenkins tool which will able to know, like whenever he will commit a new changes, Jenkins will come to know new changes has been committed. It will automatically take the code and it will deploy to the production server. Okay, he will deploy it to the production server. So again, so how it will shorten the SDLC? Earlier what used to happen in different models, the developer was completely writing the code, then only the testing will be done, carrying forwarded, then only it will be deployed onto the production server. So now what is happening, whenever he is pushing the latest changes, I have rated various stages into the Jenkins, so it will pull all the latest changes from the GitHub, right? So if you have seen my previous project, right, there in Jenkins there were various stages. We were performing unit testing, integration testing, maven build. So these all things is already written into the Jenkins file. So here automatically after unit testing, integration testing is happening, after integration maven build is happening. So using a single tool, don't you think like how it made the life easy? Okay, nobody is waiting here, no testing team is here. Actually all the test cases and all you can once the developer has written the test cases and all that, also you can integrate with the Jenkins and you can run those test cases as well. So this is how the flow has been maintained and it has sorted the SDLC. There are various software, there are various DevOps tool which made the life easy. Again, apart from that, what it does, so whenever you are delivering some feature or fixes, you can update it frequently. Like some bug came, some bug came. Again what will happen, again what will happen, whenever a bug will occur, the developer will do what, developer will again push the code to the GitHub, fixes to the GitHub. Again Jenkins will do what, pull all the latest code with the bug fixes, and it will automatically deploy onto the production server. So there is no man sitting behind this, right? There is no man sitting behind this. One time you have written the Jenkins file, and the code or the bug fixes, whenever it is coming, it will be directly deployed to the production server or any server. Okay, so like this you can say, while delivering any feature or fixes, it will be get updated frequently. Okay, now we will see about DevOps life cycle. We are starting with the DevOps life cycle. So DevOps lifecycle, as we saw, based on these five phases, that is continuous development, continuous testing, continuous integration, continuous deployment, then continuous monitoring. So these things we have already saw here, like DevOps approach consists of various stages. These are the five stages. So coming to continuous development, this is going to be the first thing. Okay, where you will be planning about the code, correct, how the approach would be. Correct. These all things you will plan here itself. Once you are done with the planning, you will start writing the code. All right. Once you have done the coding part, you will build the code. So think of a simple thing, like first you have implemented the login functionality for the first time. Okay. You have made the plan for login functionality. You have coded it. Once you have coded the login functionality into Java code or something else, like either it is .NET or Java, you have built the code. Okay, so what do you mean by build? Build is also called artifact, or it is also called compilation. So see, think of a simple scenario. If it is a Java code, you cannot directly deploy it to some, like if it is a Tomcat server. Okay, Tomcat server, like whenever you write a code, you deploy onto some running server. Okay, if you have heard about EC2 instances, if you have heard about your local server, where if you have ever installed some PHP, right, or any kind of application, in the same way you would be needing a server where you can deploy the code. Okay, let's come back to the topic. If you have a Java code, you cannot directly deploy it to the Tomcat server. Okay, how you can deploy? You have to first build the code. Once you will build the code, you will get some jar file. If it is a Java code, then I'm saying, or var file, and that var file you will copy it to Tomcat server. Okay, so you can see here, this is the way you can deploy some code onto some server. Or if it is not, then you can do what in later thing, we can build a Docker file. We can, using the Docker file, we will build the image. So in the Docker file also you will be copying this var file, okay, from the local. So like this, once your code is ready, logging functionality is ready, we will build the code. Once the building once we got the artifact, okay, so that you can store it onto somewhere, like you have Nexus repo, you have JFrog, where you will basically store the version, different version of the code. Then you will perform the testing, okay, onto the login functionality. Once the testing has been passed, you will go for deploy, okay, and you will start doing the operation kind of thing, okay, and then you will start the monitoring of the application once you have deployed the application, okay. Think of a scenario again. While monitoring, you got some issues with the application, so again the monitoring team will tell the developer, this is the bug I'm getting. Again the development team will do what? Again, so he is still working on some code, right? Now registration, login plus registration, it will be plus bug fixes. So again it will do what? Along with registration, it will have the login functionality. Login was already there. Along with that, he was working on currently registration. Then he has come to know some bug in the login functionality. He has made changes to the code, okay, for the bug fixes. Again he has written the code. Again he has built the code. He has tested the code. So these all things which is happening using a tool that is called Jenkins, okay. These all operation will be carrying forwarded with a CI tool, continuous integration tool, that is called Jenkins, okay. So once testing will be done, it will again get deployed to the production server, and again we will start monitoring the health of application, health of server and the application, okay. In the same way, we can see how DevOps made it very easy, okay. So you are getting basically feedback, okay. On the feedback you are working again and again. In between you can see there is a continuous integration as well. So it is doing what? With the developer and with the DevOps engineer, you can see it is trying to continuously integrate. So that is why, you know, the DevOps symbol came in picture, this 8 symbol, okay. Again monitoring will give some feedback, again development will happen, testing will happen, again we will deploy it, again we will start the monitoring. So like this it goes, okay. All right, so hope you are able to understand this DevOps lifecycle. Now I will try to explain each and everything one by one. Okay, so first is continuous development. Continuous development. So what is continuous development? It is one of the phase of DevOps lifecycle where we do what? We plan. We do planning and coding. All right, coding of functionality, not complete application. So DevOps, you know, in chunks we do develop, like first login, then registration. So in continuous development, basically you do this. Okay, so for continuous development, we do not have as such any software, but the coding part which you are doing, to maintain that, we would be needing some kind of repository, right? So that we can maintain the version. Okay, so to maintain the version, we have various tools, like we have Git, we have SVN, we have Jira. This Jira is to track the task. Okay, first day you will get a ticket like create login functionality. After some day you will get develop the registration functionality. So this is a project management kind of tool, and this is a Git is a version control tool, okay, where you will be writing the code. Okay, apart from that, you know, to compile the code, you can use either Ant or Maven or Gradle, etc. There are various tools. So these are the things. So these tool will do what? It will help you to build and package the code into executable. So as I have given you the example here, right, you cannot deploy a Java code directly to the Tomcat server or any server. For that, first you have to build the code using some tool like Maven. I have built the Java code. I have received a tar file or jar file, sorry, word file or jar file, and that tar file I have copied to the Tomcat server. And then once we have copied to the Tomcat server, we can access the application to the local host if it is running into the local. If we will hit this in browser, we can access this application, right? So that is why these tool will help you to build the code and get the war file. Next is your, so apart from that, let me explain you something. So these are the tool will help you to build the code and get the executable. Okay, and here one of the most important tool for code versioning, Git, is a versioning control system. Okay, so versioning control system, for version control system you will use Git and GitHub. Okay, using Git, whenever suppose a developer is writing some code, many developers are writing some code. Okay, so they will be working, they will be committing the changes onto some central repository that is a remote repository like GitHub, SVN, whatever I told. Okay, so they are, you know, they are committing the changes to the central repository, and all are on same phase in the sense he knows like he is working on, I am working on login, he is working on registration, he is working on logout functionality, right? They are working individually, but they are merging a code at a same place. Okay, although they will be working on different feature branch, but they will have a final branch, right? Main or master branch mainly, where they will be merging all the code, and they will get a complete code which will have login, registration, and logout kind of functionality. Okay, but right now they will be working on different feature branch, but they are aware of this, like who is working on what functionality. Okay, so apart from that, you know, what does Git do? Think of a scenario. Think of a scenario like there is a team of 10 developers working on a same project. One of them has done some wrong commit. Okay, and it, the changes he has done, due to that the code started breaking. Okay, so how we will get to know like who has made the particular change? So then Git will come in picture. The Git will have some unique commit ID. Along with that, you will come to know what is the mail id and the name of the person who has done this particular commit. You, it would be very easy to track. Okay, okay, this was the first scenario. And if suppose like you, if you are keeping your code to the local itself, okay, local means you are writing the code into your computer. Okay, and after some time your system will, you know, system system will fail, or something wrong will happen with the system, then you will lose your code, right? So that is why Git came in picture. So don't keep the code into local. Okay, push it to some central repository that is called GitHub. Okay, so many developer working parallelly, they will push the code to the GitHub. And one more thing you should know, like whenever suppose the central server will get failed, in that case you will have the copy of the file present into the local itself. Okay, if you have mistakenly deleted the file from local, you can still get the code from your GitHub account, right? If this will get fail, still you have the code into your local. Okay, so this is how GitHub will help you a lot in continuous development. Okay, now we will go for the next topic, that is continuous integration. So into continuous integration, let me explain you by a scenario. Okay, so suppose this is a developer. He has written some code, he has done some changes and committed it to the GitHub. Okay, and here we have a DevOps engineer, and he is using Jenkins. So Jenkins is a continuous integration tool. It continuously integrate each and everything. Okay, so DevOps engineer Jenkins will automatically pull the latest changes or the code. Okay, so in this scenario, whenever a new feature or functionality integrated with the existing code, okay, then continuous integration will happen. Okay, suppose previously it was just a login functionality. Now when login functionality and it has been deployed to the production server, again for the next time it will be login plus registration, right? Again it will do what? My Jenkins will come to know through webhook. It will automatically come to know like latest changes has been pushed. Now developer has committing the changes for login registration as well. Login was already deployed, right? Along with that he has done some changes for registration as well. So Jenkins will pull the latest changes using webhook. He will come to know, and he will again deploy the code to the production server, right? So in this way the latest changes will be continuously reflected to the continuously will get reflected to the end user. So in this case, now you can understand like we are having a tool that will check how current changes will react with the previous changes. In the sense, like it is trying to integrate with the new changes whatever we are implementing. It is continuously pulling the changes, deploying onto the production, and making it live to the end users. Okay, so to understand this continuous integration, let me explain you by a scenario. First, what will happen? First, code commit will happen to the GitHub, right? Then our Jenkins will come in picture. Jenkins will do what? Using webhook. If you are a beginner or experienced, each and every point I am saying, terminologies I am saying, just remember. Using webhook, Jenkins will come to know latest changes came to the GitHub. Now Jenkins will do what? It will again start doing its operation. It will have various stages. Jenkins will have various stages. Like first, it will pull all the latest changes. So it do git checkout. Then it will do unit testing. It will do integration testing. It will do Maven build. In case of Java, I am saying Java. Okay, Maven build. Once it will build the Maven, we will get the war file or the jar file. Okay, we will be writing Docker files, or that Docker file. Using that Docker file, we will build Docker image, and that Docker image, in that Docker image, we will push it to Docker Hub or Nexus. Okay, and that image we will deploy to the EKS cluster. So this is going to be a long list of stages, but I have finalized it here itself. Deploy to EKS, that is called your production server, or any if you are running some bare metals, okay, where you can deploy this application. Okay, so like this continuous integration helps you a lot. Now coming to continuous testing. What is continuous testing? So now whenever any new feature has been merged with the existing code, so let's take again the same example. Earlier, login functionality has been tested and deployed onto production, right? For the next time, registration function will get deployed to the production, right? So whenever software is developed, whatever software is developed till now, it will be continuously tested for bugs. So you will be keep on checking the bugs, right? And to check the bugs, you will be using many tools like Selenium, JUnit. These are some popular tools. Okay, and this does what? It will allow your QA to test multiple code bases parallelly, so that it will ensure if there is no flaws in the functionality whatever you have developed. It will continuously check if there is no any flaws in the functionality. Okay, so you can know, you do you know, like you can even automate these things, entire testing phases, okay, into Jenkins itself. Okay, Jenkins will do the testing as well. Okay, so for that, right, so Jenkins, you know, that is a CI tool that will help you to automate this continuous testing as well. Okay, and using Jenkins, you can, you know, schedule the test at predefined time. It's not like that always you will be keep on testing the code, right? So you can do what? You can schedule the testing, like after some day, or after within 3 week or 2 week, or whenever a new commit is came, then only it should test the application. So you know, you can do that as well using this Jenkins tool, CI tool. Okay, once we have seen that, we will go for continuous deployment. So this is a stage where you will finally deploy your code to the production environment. So finally deploy code to environment. All right. So this can be done using many tools, right? Earlier we were using continuous configuration management tool, or containerization tool, or orchestration tool. Okay, in configuration tool, what are the things we were having? Like, so this configuration tool, what it basically does, it establish and maintain consistency between your application functional requirement and performance. So it basically do what? It releases deployment to servers. So in earlier days, what was happening? Ansible was a tool using that, like whenever you have generated the war file, okay, so using Ansible, we were copying this war file to the Tomcat server. Okay, so Ansible was like, suppose you have 100 of server, 1000 of server. So using Ansible, you were copying the same word file onto 1000 of server. Okay, so this is something like, you can say in simple word, keeping configuration consistent across the server. Okay, and along with that, using Ansible, what we were doing, we were scheduling updates on all the server, so you can maintain as well. Okay, you were maintaining the servers as well, like latest update came, maintenance means patching the server with the latest update is, to make it more secure. So what are all the things we have into configuration tool? Like you have some popular tool like Puppet, Chef, Ansible, etc. These are the most popular tools we have in configuration management. So Ansible manages the 1000 of server, you can say more than 1000 and number of server. It keeps configuration consistent across all the 1000 of server, like the same word file can be deployed onto this much number of server. Correct. And now in containerization tool, you have Docker Swarm, sorry, Docker. And in orchestration tool, you have Kubernetes. So we will see these each and every tools in depth with the real-time use cases. All right. And coming to the containerization tool, you have Docker and Vagrant and Kubernetes that do what? That keep consistency across the different environments, like your development, testing, and stages, and production environment. Also, it will help you in scaling up and scaling down. Okay, scaling up, scale up, and scale down. Okay, apart from that, it eliminates chances of failure in any environment. Why? Because you have the same word file that is being deployed on each and every environment, so there is less chance of failure, right? You have deployed on development, it is working fine, then it will definitely work on production stage, QA. Correct. So like this works. Now we will go for continuous monitoring. Continuous monitoring. So this is a very crucial stage of DevOps lifecycle, right? What is its aim? What is aim of this particular stage? It basically improve the quality of software by monitoring the performance of the software, how the software is running, how it is handling the loads and all. Those all things we can check using monitoring. So there is a operation team, separate operation team for that. Okay, so if you joined as a DevOps engineer, you can come to the uh, operation team as well, where instead of where you will be uh, where you will be continuously monitoring the application which is being developed by someone else, or maybe you will develop the you will deploy the application, then you will be only taking care of that particular application. That could happen. Okay, so there will be operation team which will do what? Which will monitor. What it will monitor? It will monitor user activity for any bug, right? Whenever any user will try to run your application, or if you are running any application onto your system, like if you think, if you are running a simple application like Amazon or Amazon Prime, anything, there you can, if any user is using that application, he would be able to come to know this is all the fixes that need to be done. So we can monitor that as well. Apart from that, it will also check the improper behavior of your application. Okay, so in DevOps, if you don't know, like for each and everything we have seen into the DevOps life cycle, you know, there is something like we will be keep on responding. Like if you have written the code you are trying to build, it failed, again it will tell, notify the developer, again developer will do the changes, write the code, again it will build, it will go for testing, again testing is failing, again it will go to the developer, this so and so reason is there, that is why the code is failing, again this loop will go on. Okay, so this is the best thing you have about DevOps. So these are the thing we have seen. Now third point can be, so monitoring tools, using monitoring tools, what we can do, we can continuously monitor. Because if we are keeping a person to monitor, if we will keep a human to monitor these all thing, that is very hard to do and time consuming as well, right? And we can't be trustworthy that much. So that is why we are having certain monitoring tool that will, on the behalf of a person, it will continuously monitor the application based on the configuration we will do. And apart from that, it will continuously monitor what, the application performance. Okay. And once it will it will get something wrong with this, it will highlight the issue. How it will highlight the issue, as I have told you, it will respond back to the developer, like this is the issue which is getting occurred, fix it as soon as possible, since it is a production server. So some popular tools we have for this, like you have Splunk, you have ELK stack, you have Nagios, Prometheus, and Grafana. Okay. So this is about the continuous monitoring. So there are some point I would like to revise it. So it monitors the application and server and check the health of system proactively. Apart from that, it increases the productivity, increases the reliability, and also it decreases the IT support cost, right? Instead of keeping a lot of people, you will do what, you will use monitoring tool. Okay. And it will increase your IT support cost. Any major issues will come, that will be tracked, right? That will be tracked, that will be reported to the development team, and the development team will fix it in the continuous development phase, right? Whenever any changes, whenever issue will come up, the development team will try to fix it into the development, continuous development phase itself, right? And any major, okay, apart from that, these DevOps stages are carried out continuously in loop. Okay, whatever 5 stages we have seen, that will be continuously keep on running on loop until and unless we will get the desired product. Okay. Any, if it is anything, like if it is an e-commerce application. Okay, so this is this will be the end result of the all the 5 stages we have seen. So hope you have enjoyed, and in case of any queries, write write me down into the comment box below, and please do like, okay, that will motivate me to do such things more for you. And if any suggestion, any improvement you want to give, please feel free to write down into the comment. I will have a look on it. Thank you so much. See you on the day 2.